Okay, so this is the solution to quiz 3. One of you, I was just talking to one of you about the, this is not on the solution, but you used log base 2, was it? So that log base 2, so you had, was it 2 to the x equals to 5, was it? And so you said that you took log base 2 of both sides, right? And you got x is equal to log base 2 of 5, and that's not wrong, right? But then you were kind of like stuck because that's not a button on the calculator, right? So the way around this, if you take that path, is to use the change of base formula. The change of base formula is this. So you do natural log of 5 over the natural log of 2. So then those are on your calculator. You could find the decimal number for that. The other way, of course, if you don't remember the change of base formula in the future, like another way you could do it is like just go back to here and take the natural log of both sides. Because then that would also lead you to that answer, right? Because if you take the natural log of this, we get natural log of 2 to the x equals natural log of 5, which is x log 2 equals log 5. So if you solve for x, you get that as well. Like these are the... Oh, good, good. So yeah, it's just... I tried to warn you guys about this. The calculators. Well, there are some calculators with log base 2 on them. Sometimes they'll use like LG for log base 2. But okay, anyway, any questions about this one? So I think it's somewhat obvious which one's the circle, right? Like this is a circle equation, right? So it has to be the circle. E to the x plus 2, well, this should have a horizontal asymptote of 2, and it should like grow above 2. And if you look at these, there's really only one like that, which is this one, right? So that's the e to the x plus 2. Minus 4 plus 3 to the minus x minus 2. So this should have a horizontal asymptote of like minus 4. And then, well, 3 to the minus x is something that gets really, really large for negative x. So this one must be that one, because it's got that asymptote of minus 4, and it grows in the negative direction. And then, oh, and then this one, natural log of x plus 4. So that's the natural log graph shifted 4 to the left, right? I mean, correct? So the log graph looks like this, but instead of having that vertical asymptote at 0, at x equal to 0, like the standard log, it's been shifted 4 to the left. So that's how to see that. I probably will give a question like this on the test because I think it tells me a fair amount about do you understand the basic graphs, and at the same time it doesn't make me grade people graphing these things, which could be very, very bad. Very, very bad. And I think there's a greater chance you're going to get it correct than if I just made you free-form graph. I think that would be much more annoying for you. Okay, so anyway, this one, problem 2, we complete the square, right? So take half of that, and then you have to subtract the square of 5, right? Half of 4 is 2, and then you have to subtract the square of it, right? Then I move everything to the right-hand side, and I go back to my circle equation, right? So this gives me a center of 5. If I put 5 minus 2 into this, that makes it 0, right? Because the center is where this part of the formula goes to 0. Of course, that's not a point on the circle, right? But it's at the center of the circle, and the radius is the square root of whatever number goes over there, which in this case is 7. So I made it pretty for you guys. They're not always pretty, right? The radius can be something like square root of 13 or something stupid, right? It doesn't have to be nice, does it? So I don't know if you noticed or not, but like a fair number of the problems on this quiz were examples I did in class. You might not remember that. That's understandable. I mean, I'm not expecting you to memorize the examples from class or anything like that. What I want for you, of course, is to understand the concepts that we use in those examples and be able to solve similar problems. But I actually did solve some of the same problems on this quiz. So, okay, so like this one, so 16 is 2 to the 4th, so we can use the 1-to-1 property. Now, of course, there's any number of other ways you could have worked this, right? If you could take the natural log of both sides, you could solve it. So many different ways you could have done this one, but the answer is 7/2. This one, problem 4, That does not have an inverse because it fails the horizontal line test. Okay? This one passes the horizontal line test, so it has an inverse. How do you find the graph of the inverse? Well, you just pick some points and flip them, right? So this, on the graph, the original graph, you got -6, 8, right? So on the inverse graph, you flip it to 8 minus 6. This 0.46 flips to 6.4. 6.4 flips to 4.6, and then it's still a line, so you just connect the dots like that. And of course, you could track 3 points if you're, if your shape is more nuanced, if it's not just a straight line, track 3 points and flip them, and then connect the dots. Basically, is the method to use here. That kind of problem. Now the next problem, we didn't have a graph, right? But we had to find the formula for the inverse. And so we did a few of these in class, right? And the method we used was like a 4-step process, right? Step 1 was write y equals f of x. Step 2 was to solve for x, right? Step 3 is f inverse of y is equal to the stuff in y that we found, right? Which in this case is that. Now, step 4 I didn't even use here because I asked you just to find f inverse of y, right? If I'd asked you to find f inverse of x, then we would have needed to switch the letter from y to x at the end. Now, if you solve this problem and you gave me the formula for f inverse of x, I'm not going to take points off, right? Because I'm happy that you understood it. But, to be fussy, I should take off points, but I'm not going to do it. If you have the correct formula but with x there, I'm very happy still. So, what's the domain of the inverse function here? Well, you need the denominator to not be 0, right? So we just take the real numbers and get rid of 3. But here's the neat thing. Remember we talked about this, that the domain of the inverse function was the range of the function, right? So by calculating this inverse function, you have now learned what the range of the function was, right? And that's really neat because otherwise, how do we find range before? What do we do? Pretty much only had one recourse, right? Which was to graph it. We graphed it, we looked at it, says the possible y values which are attained is the range. Well here, we don't have to do that, right? From the formula I can see that the range is this. So the range of the function is the domain of the inverse. Any questions about this one? So I should, it's conceivable that the inverse function question on the test is more interesting in the sense that I could make this problem also about natural logs and exponentials, right? Like, don't be scared of it if it's got that. For example, if I had f of x equals to 2 plus 6 to the x, and I wanted to find the inverse function, how would that go? I write y equals 2 plus 6 to the x. I isolate the 6 to the x. I take a log base 6 of both sides. And then that's x equals to log base 6 of y minus 2. And there you go. F inverse of y is log base 6 of y minus 2. See, so this problem could also involve exponentials and logs, like theoretically, right? I made this problem not involve exponentials and logs because when we did these problems, right, that was before we knew about exponentials and logs, right? Hey, but now we know about exponentials and logs, so in principle, this problem can involve the later material. Yeah? That is something, and I didn't do that on the quiz, partly because I don't think that's a thing that I really emphasized much in class. Sorry, I'm my own worst cameraman here. Okay, so just a word on that. So problem 6, you've got this problem 6 looks, its bark is worse than its bite, right? Log of e to the x is identically x, right? The log of e, natural log of e is 1, so that's just minus 6. The natural log of e to the 8 is 8. So this is literally the equation x minus 6 equals to 8. The solution is x equals to 14. I have not looked at your quizzes yet, but I'm sure some of you worked much harder on this than that, right? I'm sure I'm right. So try to take stock of what you got wrong, what you're missing. There's probably just one or two facts that you haven't really assimilated yet. Once you assimilate those facts, then all of a sudden these problems become much easier, right? Log base 3 of this is equal to log base 3 of that. So by the one-to-one property of log base 3, we have 3x minus 1 equals x plus 5. Now, the way I was doing this class was I was raising both sides, 3 to both sides, right? And we get to the same point. So like you can look at that different ways, but at the end of the road, we should all get to x equals to 3. So I'm not, by the way, endorsing any of my solutions as being the only right way to do it. There are more than one right ways. There are multiple ways that are correct ways to solve these problems for sure. So problem 8, we have log of x squared minus 3 log of y plus 1 plus 2. Now that 2, that probably stopped some of you, right? What do you do with the 2? So the 2 requires a certain amount of, in some sense this is maybe one of the harder problems on the test, right? Because this step of taking 2 and making it into a log is not, if you haven't had that thought before, it's not an easy thought to have, right? I mean, that's kind of surprising, that step. But 2 is log of 100, right? Because 2 is, log of 100 is log of 10 to the 2, right? And log of 10 to the 2 is 2. So if I had a 3 there, what would I have put? Not plus log of 100, but log of 1,000, right? If I had, minus 2, it would have been log of 1 over 100, okay? Okay, anyway, so then I put them together, I get log of 100 times x squared divided by the log of y plus 1 cubed. Any questions about that one? Or this one here, the square root I brought out to give me the half, right? And then I've got log of x to the 5th plus log of y minus the log of z cubed, which then bringing the powers down, I've got a 5 here and a 3 over there. Multiply the half through, I've got 5 halves log of x, 1 half log of y, minus 3 halves log of z, but I've defined log x, log y, and log z to be a, b, and c respective, so there's your answer. Now, in this problem, if you've written your answer like the step above, I'm probably not going to take points off because I'm still pretty happy with you. Yeah, but technically speaking. I was trying to mimic that homework problem with the u and the v in it. Remember that one? There's a problem where you're supposed to write your answer in terms of u and v. That's the spirit in which this problem was written. Yeah.
So the problem, if you didn't realize that you needed to take a log and you got the x squared over y plus 1 cubed and you just put plus 2 on the outside, you're going to grade that partially.
Oh no, I'll give you significant partial credit for that. But yeah.
So I did the same
Mm-hmm.
thing.
Now, I will be more harsh about the. I'll be much more harsh about the partial credit. If this comes up on the test, I will be less kind. But yeah, I probably won't take more than about a half point off for that. Although I hate to grade in half points. Okay, it's my own stupid fault. Okay, so I used to, before Liberty forced us all to have a 1,000-point grading scale. The year before this happened, which was a while ago now, that we were all forced into using a 1,000-point scale. There was a time you could have gone to this university, and in different classes, you'd have different systems of points. And you'd have to figure it out for yourself as students. But then for whatever reason, we thought, no, we can't have that. We must have everyone doing 1,000 points. But the year before we did that, I had 10,000 points. 10,000 points are more fun because then every test has got like 1,000 or 1,500 points, and homework assignments have like 100 points. So when you're grading, it makes it way easier because you never find yourself like trying to take off a half a point or something on a quiz, right? All the quizzes are worth like 300 points or something if you use a 10,000 point scale. But anyway, I argue that my grading scale was 10 times better, but that's just because I'm an idiot. Anyway, so yeah, we'd already talked about this one, didn't we? So I get about 2.32 for that one. I hope you did too. This one here is, a little bit more of a problem. So to solve this problem, we use laws of, I have trouble saying laws of logarithms, but the log law. So this is equal to that. Now there's strings attached to that, right? Which is that both x and x minus 6 are positive, right? And we will we will come up against that as we solve this, right? Because one of the x's we're going to solve for, we get a -2, right? So -2 doesn't actually make sense back up here. And also this step technically is not legit when x is equal to -2. Anyway, so you do that, then I take 4 to both sides, I get this, I rearrange it, I factor it, and what happens? Well, I get two solutions. Potentially, I get x equals to 8 and x equals to -2, but I have to rule out x minus 2 as extraneous because when I plug -2 back into the original equation, it doesn't work, right? So I just get one answer here, 8. So I think we had about, what, like 5 or 6 homework problems, which were more or less that problem in one way or another. I'm not sure there were 5 or 6, but there were a few. This one here, this is the slightly tricky problem in the sense that you have to make this substitution. So we did do an example like this in class. I didn't belabor it. There were a couple of problems like this in your homework. It's understandable if you didn't notice it and didn't pick up on it, but focus your attention on it now. Make sure that this problem doesn't get you if it comes back on test 3, right? Everybody can do this. You just have to identify your foe. And I would say, okay, as I think about problem types, either you've got a problem where you've got 2 different bases, right, on both sides. In that case, you just take a natural log and deal with it, right? But if you've got more than 2 terms, like if you've got 3 or more terms and it involves exponentials, it might be one of these, especially if you're looking at a base and then that same base raised to the second power of what you're looking at, then that kind of says to me, maybe this is one of these kind of problems. There are problems that have 3 terms in them where what you do to solve it is just to add the term to the other side and then exponentiate or take the log of both sides or whatever. But I think these are identifiably different. Anyway, so I make the substitution. I get my quadratic. I factor it. I get either 4 or -1 for this one, right? But, of course, we can't solve e to the x equals to -1 because we know that the range of e to the x is 0 to infinity, right? So when you try to solve e to the x equal to something negative, you can't do it, right? If you take the natural log of both sides, you'll get natural log of -1 says what? Error, right? So if the calculator says it, it must be true, right? Take the natural log of this, we get x equals log 4. That's your answer there. All right, so number 13, I'm hoping a lot of you got number 13 right. Usually students can get this one, a lot of people. Now, if you wrote your answer as x equals 1 box, y equals 2 box, totally fine with that. That's an answer. That's a legitimate way of writing the solution for this problem. Typically, we try to write the solution as an ordered pair, like 1, 2. That emphasizes the fact that you're solving them both at once. But, honestly speaking, from a logical perspective, this is a good answer, or these 2 taken collectively is a good answer, all right? And how you do it is your business. Like you can do substitution, you can add, there's so many different ways. This one, some of you may have just guessed the answer, and I'm also fine with that. Like, hey, if I make my answers whole numbers that are small numbers and you can just guess them and see that it works, I can't rule that out as a proper method of solution. It is a method. Guessing is a method of solution. We shouldn't forget that. It's also a very dangerous method of solving problems, right? Guessing is kind of, not the best. Problem 14, I would say, is of the same variety as the very tail end of, I forget if it was homework 13 or 12, but there are some symbolic problems. Not exactly like this, but I thought I should ask something which basically is conceptually linked to the things you've done, but not a problem you've seen before. I think this falls in that category. So here, what I did was I took the natural log of both sides, simplified that, used the property of logs to isolate the a, log of a, right? Subtract log b to the other side. Then I took both sides and exponentiated at base 10 to get this. Now, notice that this is the same as log 10 to the log c times 10 to the log of b minus 1, right? But that is identically 1 over b. So this is the nice way to write the answer. Now, if you wrote your answer, there are other ways to make that formula. which you'd still get full credit for, because I didn't say solve for A and simplify. I just said solve for A. So if you've legitimately isolated A using proper mathematical steps, I will still give you full credit there, period. And then problem 15 is this one. So this is the very last batch of things we did, besides, of course, solving the nonlinear problems, right? But I figured you guys would have enough trouble with the things I've already put on you for this quiz, besides adding one of those nonlinear problems. I'm not promising that the nonlinear problem's not on the test. To be clear, that could appear. Like that last homework we had, the last about 5 problems were on solving nonlinear equations together. So there are, yeah. So, I mean, I've done the best I can to represent the material with quiz 3, but I'm not guaranteeing that test 3 is exactly the same. It's probably going to be 90% the same things, but there might be a little bit of difference. Anyway, so you plug in the points, right? And I put x into the x, I put y on the other side, f of x equals to y, right? So f of 0 is 3. Well, that immediately gives me c equals to 3. So that makes this problem like way easy compared to other problems like this. Because while it appears to be 3 equations and 3 unknowns, it's really just 2 equations and 2 unknowns after that point, right? Because you've already eliminated c rather, and when you plug that into the other 2, we get 2 equations, 2 unknowns, which are pretty nice. So we can add the equations, we immediately get a equals to 2, and plug it back into the other one, you get b equals to 1, which then, putting this all together, gives us, there's the quadratic that does it for you. Anyway, hey, that's it. I think we're out of time. But you notice this stands in stark contrast to earlier questions we asked about polynomials where we used what? We always used the factor theorem, right? So why didn't we use the factor theorem here? I didn't give you zeros, right? We need to have zeros to use the factor theorem. Here we don't have zeros.